Hello, everybody. Today, I want to talk about stock price prediction. There's many ways to predict what the price will be for stock tomorrow and next week and next month. We're going to focus on three methodologies in this video today. LSTM model, which is long short-term memory. This is a type of a recurrent neural network, an abbreviated RNN model, and we're going to look at using a different approach, two deep learning approaches, TensorFlow and PyTorch. So the RNN LSTM is sort of more like a classical statistics, long short-term memory concept where there's more emphasis given to more recent events and less emphasis given to less recent events, but they're still taken into consideration. So it's just higher weighting applied to the more recent events. What happened last week and last month is more relevant than what happened 6 months ago. And TensorFlow and PyTorch are more like deep learning patterns and data like a human being would learn. So more abstract type of learning, a little bit harder to understand, a little bit harder to explain, but through trial and error, you can teach them all to learn whatever it is you're learning. And in this case today, we're looking at future stock prices. So TensorFlow is an ecosystem with integrated tools. This came from Google about 12 years ago, give or take. It's great for mobile development and deployment and model training and model serving. It's great for handling large amounts of data, huge volumes of data. Can be trained and learned through TensorFlow. PyTorch is somewhat similar, more dynamic computational graph. It's called eager execution, which is intuitive for debugging and experimentation purposes. PyTorch has a way of looping. It's called an epoch. TensorFlow also uses epochs, and both perform somewhat similar. There's fine-grained control and all kinds of parameters that you can tune to train the model to be more precise and make even better predictions if you're not satisfied with what you're getting. And last point here is that there's an API with deployment tools for TensorFlow, and that might be the way to go if you need that API, and PyTorch might be the way to go if you need more flexibility and ease of use in your experimentation. So let's go ahead and import our historical data. I've got a couple things. I think I actually have a couple superfluous libraries in here that I'm not necessarily using. I copied this from another example, but that's fine. It'll run nonetheless. The most important thing here is to look at this library, yfinance. So this is Yahoo Finance. We're getting all our historical prices from the Yahoo API endpoint. So I'm going back in time 6 months. So I'm saying get the current time and date and go back 6 months from today. Now 6 months is somewhat arbitrary. You can look at 3 months, you can look at 12 months, you can look at years and years of data, right? You can go back 5 or even 10 years of data, but I don't think that's too relevant. Like I said, in the current state of the economy, things are changing pretty quickly and dynamically. Going back 10 years doesn't really make a whole lot of sense now. Maybe a long time ago that made more sense. Now things change very quickly. I'm more interested in trying to understand what's happened recently, and I don't have a huge concern about what happened several years ago. It's just not that relevant. There's so many things going on now. I would say maybe since about 2008, since the financial crisis. The world has been a very different place ever since that. So I'm not concerned about the what's happening a long time ago. I'm much more focused on what's happening just 6 months, within the last 6 months. But again, this is arbitrary, so you can pick what you want. Okay, I made this very dynamic. So all you have to do is pop in a new ticker symbol here. It could be Microsoft, Starbucks, whatever stock you're analyzing. I'm looking at Apple today. I'm going to go ahead and hit Control, Enter, run the code. Okay, it's done. It does the fetch pretty quick. Yahoo Finance has been refined to be super high performant. Okay, so we can see the head of the data and the tail of the data. I'm displaying these two right here. So we can say it starts with 2/13/2024. That's 6 months ago, and it goes up till actually today, 2/21. So if you look at Yahoo Finance right now, 221. I think that's what we're going to see. 221. This is in real time on August 13th, 2024. So 221. That's exactly what we're seeing here. Okay. So that's today's data. I want to predict the stock price for tomorrow. So rather than wait a whole day and pause the video and then come back tomorrow and see what the stock is trading at, I'm going to chop off one day and make it appear like today is August 12th, even though today is actually August 13th. So let's go back here. We're taking off the maximum date, and you can see for the model purposes, all the model knows is what happened yesterday. The closing price was 217.52 yesterday, which was what, Monday, right? So today's the 13th. I'm going to kind of trick the model and tell it that today is the 12th, but I want to see if it can make the prediction today to get today's data. Okay, so we're going to do a couple things just to understand what the trends over time and what's been happening with this stock price. So we're looking at moving averages. This is good for trend identification, signal generation, buy or sell signals rate, trend confirmation, risk management, flexibility, and customization of the model that we're going to be working with. And then any kind of enhanced analysis can be very important based on visually understanding what the stock price has been doing for the last 6 months. So I'm looking at some moving averages here. This is the 7-day moving average, 21-day moving average, exponential moving average for 26 days, for 12 days, and then the MACD. We're also looking at rolling windows, and then we're going to set an upper band and a rolling band based on the 21-day moving average and multiply the standard deviation by 2 to see what the thresholds, upper and lower thresholds are of the stock price movement. So all of that is set. I'm going to run it. Okay, Control Enter to run this thing, and we can see the output here. These are the new features that we created just on the adjusted closing price. Now we have a moving average of 7 days, exponential moving average, upper and lower bands, and so on and so forth. And we see the overall momentum. So this is called feature engineering, where you create new features from pre-existing features. Before we just had one feature. Maybe I guess you could call it two. We had the date and the adjusted closing price. Now we have close to a dozen features. Okay, you can see the plot over here. You can see the moving averages over time. So Apple is tending to go up over time. So this was a pretty good investment as of back in February, I guess. Mid-February is when we started pulling the data. And again, it ends today, but then we chopped off one day. So for the model, it really thinks that it's August 12th. Okay, so that's important. We just want to see what the price is when we go ahead and run the model. That's going to be in the next step. We're going to look at one more Fourier transform, one more simple trend analysis here, Fourier transform. This is to decompose the stock price into frequency components and see over time how the stock price moves, right? So go ahead and run that. You see the Fourier transform with 3, 6, 9 components and 100 components. And again, you see the same kind of pattern, right? Up and to the right. So overall good investment, pretty positive since mid-February. Okay. So now we're going to go ahead and run the LSTM model. So this is the RNN, recurrent neural network. And again, this is long short-term memory. So there's more weight given to the more recent transactions or closing stock prices, right? And less given to the older, more historical, closer to 5 and 6 months back in time. We just don't care that much about those. It's an older event, older stock price. We're more focused on what's happening more recently, right? In the past couple of weeks, not in the past couple of months. So I'm not going to actually run this. I ran this just before I started the video. It does take a little bit of time to run it, probably a good 15 minutes to do all the epochs for all of these models, but I will show you the results. So when I did this was just setting up and preparing the functions for the model. This is the first model I'm running here. This is the LSTM. Okay, so long short-term memory. I ran it. It did 100 epochs. You can set the number of epochs over here. Where is it? Or, it might be actually in the function that's set. Not seeing it right here. Where is that? You can set the number of epochs because if you give it more epochs, it's going to do more and more loops and continue to train and test the model. Let me do a control search 100. Oh, there it is. Yeah. Okay. So epochs equals 100. So if you set this to 1,000, it's going to do more iterations, more loops. That's what an epoch is. It's a short loop of training, and the model will probably predict more accurately what the future stock price will be. I think 100 is sufficient in this scenario. You can certainly go up to a couple hundred, 500, 1,000 if you think it's going to increase the performance. That's one way to fine-tune the model, but you can change the hyperparameters as well. If you find that some hyperparameters are able to make better predictions, you can tune that as well and get a more accurate future stock price prediction. So this is LSTM. It predicted 221.59. That's what the stock is going to be. Remember, we cut this off at August 12th, and today's the 13th. So if we look at the price on the 13th on Yahoo Finance, 221.50. Right now, this is in real time, and this model is saying 221.59. So that's almost spot on. I mean, you're off by a fraction of a percent. So that's pretty impressive. This next model is the TensorFlow. We're doing stock price predictions with TensorFlow. Again, you can set the epochs down here. Similar concept. This is looping 100 times. I'm not going to rerun it because I already know what the outcome is going to be. It takes quite a while, probably 10-15 minutes to do 100 epochs. This is telling me 217.28 or 22. What is that? 217.22, right? But we already know the stock price today is 221, so that came in a little bit under, probably 2 or 3% under. If we listen to this model, we probably wouldn't buy Apple because we know that it closed yesterday at 217. We'd expect no price movement. This model was actually correct. It said the stock is going to be 221 today. So if it closed at 217, we know the stock price is going to go up today. How much? Okay, about 1.8%. So the LSTM was more accurate than the TensorFlow. We can change the number of epochs and rerun this. We can change a few of the hyperparameters and tune that and retrain it and see if we can get more accurate. It is off by about 2 to 3%. Here's the last example I'm going to show you today. PyTorch. Again, you can train the model, test it. Number of epochs in this case is set to 100, just like we saw previous. I'm not going to run it. It takes a while to run. I did run it just before I kicked off this video, started recording this video, and this again came up with 217. So slightly off again, about 2 or 3%, very similar to what TensorFlow was telling us. But yeah, it came up a little bit short. So in this case, the LSTM model really outperformed the other two. And I think it's totally fine. I think TensorFlow and PyTorch are a little bit more deep learning, more complex data. It's not designed for structured data. That's what we're dealing with here. And it's not great at columns and rows of data. That's what we have in their data frame. It's more for ambiguous types of data, classifying types of images, understanding books or dense text, analyzing data from sensors or cameras or something like that, or audio, video data. TensorFlow and PyTorch tend to perform very well in those scenarios, not quite as well in column and row data, what we're seeing here. So the LSTM model seems to be the way to go. I'm going to post all of this code online and share it with everybody. All you have to do is copy and paste it, run it in your own Jupyter notebook. Again, the date I picked was somewhat arbitrary. Okay, I'm going back 6 months. And you could certainly change this, go back 3 months, go back a year. I think 6 makes sense in this case. So all you'd have to do is change that, and then the ticker, add in whatever ticker you're analyzing. Could be anything, right? Like Yahoo Finance has, I don't even know how many, I think 50,000 equities that they cover. So pretty comprehensive. The last thing I'll say is this is not investment advice. Okay, if you use this methodology and you lose money, don't get angry at me. Don't try to sue me. That's not going to happen. But the model does what it's supposed to do. It's supposed to make stock price predictions. Came up very accurate, certainly more accurately than just throwing darts at a dartboard or just randomly tossing your money into the market and you really have no clue what's going on. This gives you a lot of insight, a lot of intelligence, so you can make a very meaningful investment decisions, and probably make a very decent return, right? Again, not investment advice, but definitely gives you deep insight into how stock has been performing historically and making a prediction into what the stock price is going to be tomorrow. Okay, this is one day look ahead. Okay, thanks for your time today. Have a great day, everybody. Bye.